Okay, so listen, what do we got here? We've got now a collection of gas, and we've got gas up to here in this one, and we've got gas down to here, right? It bubbles up and collects at the top, right? It's the collision game in action, and if we read this, we can see that this one, there are 8 units of gas, and this one there are 16 units of gas. Now, maybe you didn't predict that, but I sure did, right? H2O, twice as much. There are 2 hydrogen atoms, H2, for every O, for every oxygen atom. Okay, so that's water. 2 hydrogens, 1 oxygen. I know most of you, or all of you, probably know that. And that has played out here. Okay, we can see that, or at least we think that's what we're seeing, right? We see 8 units over there, and we see 16 units over there. Now we also, if you think about oxygen and hydrogen, okay, we have the oxygen collected at the red. Okay, and oxygen, if you think about it, gains electrons, right? Do you remember that? Every hydrogen atom is a bully, and it has to gain 2 outie electrons to become stable, while hydrogen is the wild card, right? That's the term we used, and they can lose electrons, become more positive, or gain electrons and become more negative. So that's good evidence. But what I'm hoping to do here is to collect a little more evidence. So what do we know? What do we know about hydrogen? And I'm going to, we know it's lighter than air. People say, I would say that it's less dense than air, or that it loses the collision game to air. And so I'm going to open this valve. Okay, and come on. There we go. And so I'm going to speculate that this test tube is now full of hydrogen, which is collected in the top of the test tube. How can we see whether that's really what it is? So first I'm going to put on my safety glasses, not because there's any danger, but just because it's good role modeling. And then I'm going to light this little birthday candle, and then we're going to see. What do we know about hydrogen? Okay. Pretty good little explosion there, right? Ever hear of the Hindenburg? Hydrogen reacts with oxygen. Oh, darn. I should have showed you right away. There's water on the inside of that test tube. Can you see it? Just tiny little bits of water, but it's, you know, definitely like a cloud. I have no idea whether you can see it or not. That's what formed. There was hydrogen in there. I gave it a little bit of energy, and bang, it reacted with the oxygen in the room, released some energy, and formed water. We don't have a way to measure the H2O ratio in that, but we had some good evidence to believe that that's the case. All right, so I find that very conclusive evidence that that tube was filled with hydrogen. The oxygen, you can see we don't have as much of it. I'm running out of time a little bit here. I would have loved to have waited, but I'm going to get the gas out of there and into here, and I'm going to put my thumb over it now because because oxygen is about the same density as air. I don't want it to leak out. What do we know about oxygen? It reacts with Stutba, right? To burn. And so what I'm going to do is I'm going to take some Stutba, some wood here, and I'm going to light it on fire, then I'm going to blow it out. And then I'm going to stick it in here. Up, and darn, I didn't get enough oxygen. If I'd had some more time, this would have burst into a flame if there'd been enough oxygen in here. I don't think I'm going to be able to do this again. either way, what we've got here is, pretty convincing evidence that there's a 2-to-1 ratio, which you've heard about your whole life, and that is what we're talking about when we call it H2O. Okay, we're going to talk more about ratios this week. I've probably already given you another video and called it the introduction. Okay, want a quick look around the room? I wish you guys were here. I will be talking to you again soon. Bye-bye.